Africa. So let's focus on the existing countries. So we are active in 7 countries: Angola, Congo, Gabon, Libya, Nigeria, South Sudan, and Uganda. Dietsmann has been working for the last 40 years in the African continent, and of course there are lots of investments in the existing countries as well as in new countries. The total manning in Africa on our project is roughly 2,100 people. 68% of those people are local employees. So the local content is even above the local regulations. And we are going to increase it and to go up to 75%. That's the target for the next 2 years. Man hours in Africa are 3.9 million. And there are quite a few targets, so that says a lot about how we would like to widen our business portfolio in Africa. Undeniably, Algeria is one target for the short term. Senegal and Ivory Coast, although we have already some small projects ongoing, we would like to increase our presence. Namibia, being a maintenance contractor, operation and maintenance contractor, Namibia is for sure a target, but for the mid and long term, because the discoveries are quite recent, and of course the assets will become operational in the next few years. South Africa, from a power plant point of view, is undeniably a target for Dietsmann, and Mozambique for both power and LNG asset point of view, it's a target for Dietsmann. Environmental data. We are very committed to the energy transition, of course, also to decreasing our emissions on the 3 scopes. So scope 1, scope 2, and scope 3. Basically, being a maintenance contractor, scope 2 is a little bit smaller compared to scope 1. Scope 3, of course, is mainly based on the logistics, on the travels that our people are subject to reach the different sites. We set a parkour to become net zero in 2040. So basically, okay, sorry. So we had an assessment 2 years ago. In 2025, we are expected to reduce by 50% our emissions of scope 1 and 2, and of course minus 20% on scope 3. By 2030, we will become net zero on scope 1 and 2, and then of course 2040, as I said before, it's our target for scope 3. This is a picture of how much emission we have today within our company. As I said before, scope 2 is a little bit smaller than the others. The vast majority is scope 1 and of course scope 3. Maintenance strategy. We are a maintenance service provider, so of course we know very well how maintenance has to be done. The difference between the past, the present, and the future is how we would like to somehow improve the maintenance strategy on our side, but also in collaboration with our clients. So we would like to go to the point that prescriptive maintenance would be our pillar, our unique value proposition. Prescriptive maintenance will allow to reschedule the preventative maintenance, to reduce the maintenance cost. Of course, this is very important also for our clients, to improve the workforce, because of course the manual activities will be improved, will be somehow developed into something that is more modern, decrease the unplanned downtime, so for the clients in terms of production, in terms of flow rate, in terms of availability, there will be a big step up in reliability and availability. And of course, we would like to participate in increasing their asset lifespan. Basically, the delay is one of the key components on what we are working. So we try to reduce as much as possible the delay in moving our people throughout the different sites. The backlog, so of course, if corrective maintenance, reactive maintenance is what you're doing, the backlog is always a big problem for for the contractor, but also for the client. So by going to prescriptive maintenance, the backlog would reduce dramatically. The stock, if you improve and if you implement prescriptive maintenance instead of preventive maintenance, of course the stock, that is a huge component on the client cost side, would be dramatically reduced because you would purchase the parts just in time for the replacement. And the shipment of the parts, that is one of the worst nightmare of also the client, but of course also on the contractor side, will be optimized by ordering them according to the necessity on site. Let's talk briefly about the prevention failure curve, that is the heart of this concept. So if on the y-axis we put the asset health and on the x-axis we put the time, we see that for any assets on site there's a decrease of asset health throughout the years. So we talk about the potential failure, that is the point where you can find out that something is failing. Okay, so there's a detection that the failure is there. Of course, there's also a point where the breakdown occurs. So the functional failure is the point where you need to intervene and to correct the failure. The functional failure is somehow, if you compare to the life of a bearing, that is a very simple example, the functional failure is when a bearing would go over 60 degrees, okay? So this is something that you detect basically by the instrumentation, and that gives enough time to replace the bearing. The functional failure, of course, dictates the time between the occurrence of the time of the failure and the detection of the failure. And this is where we would like to intervene thanks to the artificial intelligence. The point where the failure starts to occur is not necessarily related to age. You may have it also on new sites, on new installations, because many elements can be behind a failure. So our program is dedicated to old sites as well as new sites. Potential versus functional. So if you can reduce the time between the point in which you detect the failure and the point where it actually occurs, that would give ample time for your teams to plan the intervention, to agree with the client the right time to stop the machine, and of course you can improve the reliability, because of course you know already when the failures will occur, but you can also concur in raising the uptime of the entire facility. This is the time, this is the PF interval, that is something that we will work extensively thanks to digital twins and artificial intelligence. Of course, we try to enlarge as much as possible this time, to have ample time to order the spares, to program, to plan, to get the teams on site for the intervention. What does it mean? That you schedule better the maintenance. So, of course, there will be no last-minute parts delivery, which is also very dangerous for an oil and gas as well as a power station installation. You would reduce the cost of the maintenance, because you will order the parts just in time when you need. So basically the stock in the warehouse of the client will be reduced to the minimum. And then of course you increase, as I said before, the asset uptime. The risk severity, that is somehow in corrective and in preventive maintenance, the asset risk is always somehow very difficult to assess in terms of severity. Here, thanks to the historical data, to the data analytics, you can customize, you can really set the severity of any and each of the failures that are going to occur. There's also somehow a very good contribution in the asset life cycle, because of course you would reduce to zero the unnecessary interventions. You will focus only on something that is extremely vital for the asset and for the entire plant. Of course, the beauty of it is that Dietsmann collaborates with the clients, and our next target would be to collaborate with the EPC contractors. Because of course, if you can already inject this technology, this concept at a feed level, at an EPC level, from day one, the client would benefit from having already a maintenance strategy towards prescriptive maintenance. If a client invests after the startup, it may be already too late for having a good reliability and a good availability of the plant. There are some factors that may affect, of course, this study, the frequency of use. So basically, how you process, how you manage the production. That's why I was talking about operations. For us, having guys on both sides of the plant, on the maintenance side, but also on the operations, that allows a very good understanding of the reciprocal needs. Maintenance and operations, if are taken apart, usually they don't communicate, and of course some problems that stem from the operations, if it's not promptly shared with the maintenance, can create huge problems on the maintenance side. Conversely, if the maintenance guys do not share what their intervention was about, the operational people, they cannot improve the process management. So it's when we talk about operation and maintenance, it's a jointly effort from both the maintenance and the operation guys. Manual errors. Of course, statistically, if you operate frequently on a machine, the room for errors can be quite high, notwithstanding the training, notwithstanding the competence, the skills, but human errors, especially in a rush, can be there. So by reducing the frequency of intervention, by reducing somehow the activities at site, we would also reduce, I cannot say to zero, but to a very low level, the room for errors. How can we go all the way to the prescriptive maintenance? So we have different components: the corrosion monitoring, the lubricant sampling and analysis, the vibration measurement and the analysis, the visual inspection, the process parameter trending, the infrared tomography, the acoustic emission detection, and of course the motor current analysis for the electrical equipment. Those are components that are already there. Our target is to integrate all those activities into a package that is, for most of it, automated and managed by artificial intelligence. So the data acquisition would be on each and every second. To be honest, the pickup frequency is 30 milliseconds. So it's a real-time data capturing. This real-time data capturing, it's generating a huge mass, a huge volume of data that is very vital for the forecast, for the prediction, but it's impossible that this amount of data can be managed by engineers. So artificial intelligence is a necessary tool to translate this huge amount of data into something that is suitable for the human beings and for the engineers. Let's speak about the cost to repair. That is something that is always behind any investments. So the cost to repay, you see that as a parabolic trend. So throughout the lifetime, usually the costs are increasing due to the age of the plant. So the prescriptive maintenance, that is our goal, would set in that flat, in that plateau trend of the asset health curve. Predictive, that is something that is already implemented by few contractors. It's a little bit later. The condition-based monitoring is even further, and of course you see that the failure starts a little bit before you can prescribe any corrective action. But the beauty is that thanks to the prescriptive maintenance, you would be ahead of the detection that is today possible. So today you can only detect the failure only after the point P. So with the predictive maintenance, you can only be there. With the prescriptive maintenance, you will be ahead of the detection. That is a huge step up in, of course, in increasing and improving the detection of failures and, of course, the maintenance quality for our clients. This is the whole life cycle for preventative maintenance. So when you talk about maintenance plant, when you talk about maintenance based on time, actually you see that it involves a very large span of time. That means huge investment, huge cost, huge manpower need at site. If you focus on prescriptive maintenance, you can reduce the cost, you can reduce the requirements for, of course, for workforce, but also the requirements in terms of parts. This is our goal. Maintenance will become very soon driven by data. Okay, so the acquisition, capturing data on a very somehow on real-time basis will allow us to analyze those data and to give guidelines to engineers and to planners to plan the maintenance according to real needs, to actual needs. Let's speak about what convenience for a client can be switching from one type of maintenance to another one. So if the criticality is low to the left and high to the right, and if the assets are simpler down and somehow highly complex to the upside of the graphic, here is what usually you are with reactive maintenance. So reactive maintenance applies to those sites that are low in criticality and low in complexity. Preventative is somehow more critical, so we are moving towards something that is more critical and less simple. Condition-based monitoring, condition-based maintenance is somehow there. Predictive, that is today the most advanced methodology for maintenance, is becoming more interesting where the sites are complex and also very critical for the export, for the output, either in terms of electricity or oil and gas production. And prescriptive is really the pinnacle, the top of everything. So when you have, every time you have an asset that is very complex and highly critical for the client, prescriptive maintenance is the answer to the client's needs. In terms of savings, in terms of cost reduction on the y-axis and cost to install and manage the prescriptive maintenance, of course, reactive is very low, so reactive applies to where the cost reduction is not so important, but also the investments are quite somehow low and limited. Preventative requires additional investments, but also the savings is a little bit higher than reactive. Condition-based, of course, is halfway between reactive and prescriptive. Predictive sets somehow there. And you see that prescriptive upfront of an investment that is a one-off investment by the client in terms of sensors and by the contractors in terms of artificial intelligence would pay off in savings in terms of cost reduction. So prescriptive maintenance on the long term, on the long run, is the answer also to cost reduction. Let me give you a very brief overview on our new advanced technologies. So the digital twins is a simulation, it's a digital simulation on how the sites work. It allows the data collection, it allows the maintenance preparation, and it also allows the work order management. Of course, by having sensors, you can translate the analogic indications into something that is digital. For the artificial intelligence is extremely important. You can, of course, manage the work preparation and also the permit to work, so you can decrease the time to prepare the intervention. And then, of course, you can track the work order execution. So the client is being kept up to date via mobile or phones or other kinds of interfaces on the progress of the intervention. In terms of robotics, I'm trying to be brief. In terms of robotics, we have three models. So we have the inspector, we have the operator, and we have the gas finder. The beauty of having the robots operational at site is that you can conduct inspection, completely automated, unmanned inspections. The robots can carry out inspections without any control by the human beings. You can, of course, get the data acquisition done because the robots are equipped with sensor to collect the vibration, infrared tomography, and other source of data. And the robots have installed software that they can somehow get already an elaboration of data already aboard the robot. So when the robot downloads the data or uploads the data into the cloud, where we have all the artificial intelligence, these data are already somehow processed and sorted and filtered by the robots by importance and by consistency. We are very much involved and committed to the emission reduction, as I said before, not only for us but also for the client. So our gas finder robot can detect methane leaks, very small, and this is something that is very good for the client because methane is 36 times worse than carbon dioxide in terms of pollution. So if you take the example of one small leak, 20 grams per second, that generates 63 tons per year of emission in the atmosphere. So if you multiply, if you translate that in CO2, then you would go to 0.2 megaton per year per site, providing that every year at site you have 100 leaks of methane. Translate that into emission of cars that is more familiar to everybody. That would be for each site per year the equivalent of 45,000 cars. That is rather impressive in terms of emission reduction. Thank you very much for your attention. If you have any questions, I would be happy to try to reply. Thank you.
Thank you so much, sir. I only have one question for you as we wrap up. How does the advancement of artificial intelligence, AI, serve operational processes at your company?
But actually, it's something that we are experiencing at this time because, of course, artificial intelligence is based on machine learning. And basically, you need some time, at least at the beginning. So when I talked about investment, it's not only money, but it's also time. Roughly for a low complexity site, we are talking about some weeks. For a normal complexity site, it can go up to 6 months. But after 6 months, the artificial intelligence is already generating some predictions in the next 3 to 4 weeks. So 6 months is the normal lifespan for artificial intelligence to become operational and effective.
And then how does it mitigate human error?
But of course, it's based on the frequency of the interventions. So the less you go intervening at site, the less your people are exposed to, first of all, HSE risks, because we have to think that we operate always in a cold environment in terms of safety, but hot environment in terms of process. So the plant is not shut when you intervene, so you have other equipment around you that may somehow hurt or may cause a risk for your people. So limiting the exposure of your people to the risk, it's already somehow a reduction in stress, and the stress would create errors on their side. So the less they intervene, the less they are stressed out, the less they can make errors.
It's all about embracing the transformation of the world that we live in as we migrate to the fourth industrial revolution. Thank you so much for your time, sir. Thank you.
Thank you, everybody, for attending. Thank you.